Now we're going to look at thoughts and consciousness. Now these are really difficult concepts, and they're only scratching the surface with understanding of what thoughts and consciousness are. But we do still have some ideas about what their characteristics are and some idea about how their circuitry works. So to that end, we will at least discuss that much. We will also discuss memory. Thought. There's no one cortical area in which thought seems to occur. And maybe a few decades ago they thought there must be some sort of central region where everything feeds into one place in the brain, and that's the end point of all conscious activity. But there doesn't seem to be a one place where everything feeds into that one place. It seems to involve many areas of the cortex, not only just the cortex, but the thalamus, the limbic parts, and even as far as the reticular formation of the brainstem, and that your thinking is the simultaneous activity of all of those things working in concert and together. That they don't have like one then higher level place where all of them then sends everything to for the final thought. It doesn't seem to be the case. That split brain phenomenon video that you might have looked at in the previous section, that neuroscientist was of the thought that there was some final place, but it doesn't seem with this decades after he did that video, that doesn't seem to be bearing out so much. However, we can make some distinctions about the types of processing that goes in generally in different brain areas. For instance, the lower brain seems to determine the general nature of the thought. Is the thought pleasurable, unpleasant? Is it painful? Is it comfortable? Just that underlying framework of that thought. The upper brain, however, has to deal with the aspects of thought that are more specific. Localization of a particular sensation, or what you are seeing in the central field of vision. What is the texture of your object, or even recognizing those objects. So things that are a lot more specific and maybe more elaborate seems to be an upper brain phenomenon. So Guyton and Hall has a nice little quote that I just took directly from it that they call the holistic theory of thought. And it states that a thought results from a pattern of stimulation of many parts of the nervous system at the same time and in definite sequence, probably involving, most importantly, the cerebral cortex, thalamus, limbic system, and the reticular formation. So I couldn't state it any better than that, so I went ahead and put a direct quote there. So what is consciousness? Consciousness can be described as our continuing stream of awareness of either our surroundings or our sequential thoughts. Now, even if we have our eyes closed and in a super quiet room, or maybe we don't have any binding clothing, so we feel as little as we can, we aren't unconscious. We can still be aware of our own thoughts, even if our sensations are pretty limited. What is memory? Memory is remembering things that you have experienced in the past, of course, and involves changes in neural pathways, it seems. So that's what the evidence seems to show, that once you establish a memory, a mind that is conscious and thinking can recall these memories and manipulate them. Any memory that is within the access of your conscious thinking mind is called a memory trace. And we have some idea of neurologically how this might happen, as we'll see in a few slides. Let's define a few memory terms. Positive memory, also known as sensitization, is any memory that is about incoming information that is somehow important to you, so that you will remember it for some length of time. Memory that is remembered or likely to be remembered is called a facilitated memory trace, and it'll be stored for some time. Now, often these positive memories are going to have some context. Like I said earlier, the lower brains have those context of emotion and things. So if a event that happens in your life is particularly unpleasant or painful, or something that is pleasurable and wonderful, those are the things that are most likely to be sensitized or be facilitated into this positive memory. And it will be stored for varying lengths of time. Negative memory, also known as habituation, is an inhibited sort of thing, where the event happens, but it's of no consequence to you, and you're not likely going to remember it. For instance, you may not remember what you had for lunch, 3.5 weeks ago or something. It's just not something that was necessarily important. However, if that 3.5 weeks ago was the dinner you had at your wedding reception, well, then that would probably be something that would be a positive memory, if that's what you had for lunch. So sure, that makes a difference, whether you have a significance to it emotionally or not. A few other terms involving memory include the term short-term memory. Short-term memory is just something that lasts for seconds to a minute, just enough time for you to maybe dial a phone number if you had to dial a phone number. Someone told you what it was and you punched it in. Before the conversation's over, that memory's probably gone. Intermediate long-term memory, that may take minutes to weeks, and that will be gone after about that length of time. Unfortunately, for many of us when we are in school, myself probably included in this process, but sometimes you will study for an exam and put it in your intermediate long-term memory, and therefore after the exam is over, a lot of it's gone. So it's kind of sad, but nonetheless, that is the case. Long-term memory, which is the goal for our studying, hopefully, is something that will be with us for years to a lifetime. That's why every time you repeat a skill or repeat studying a particular topic, the more likely it'll stay with you and help you establish these long-term memories. Working memory can be any of the other memories we just mentioned before. Short-term, intermediate, or long-term, doesn't matter. But what working memory is what your conscious mind is happening to use right now. And my best example of what working memory is, or at least an analogy, that what your computer does. Your computer in its hard drive has stored every assignment you saved onto the hard drive and whatnot. But the computer isn't using all of that memory at the same time or all right now. You have something called random access memory. So if you need to access something you typed a while ago in some Word file you saved, then you can go retrieve it. And then while it's on your desktop and you're manipulating it, it's in your working memory. So your brain sort of does the same thing. That you might remember your 12th birthday party, but until I mentioned it, you might not have thought about it in 10 years. Okay, those memories are there, but they're not a working memory unless you're bringing that memory to the forefront of your mind and considering it in some way. Declarative memory versus skill memory. The declarative memory is a memory of an experience. So if you're ever been in a class where you had to learn how to describe an event or creative writing of some sort, they always tell you to consider the where, why, when, how, and so on of whatever event you're writing about. Well, your declarative memory is about that kind of stuff. Skill memory is the motor skills that you've learned, and whether you can deliver a fantastic adjustment or what have you. That's a skill memory. Let's take a look at some more things about short-term memory. As I said, my favorite example would that be knowing your phone number, someone telling you a phone number and you punch it in long enough and you remember it long enough to dial it. The possible mechanisms of this is using some of those reverberating circuit type things that we've talked about, or something called presynaptic facilitation and inhibition. If you remember, we had a discussion earlier in the course about how reverberating circuits have an input neuron, and then you have then another neuron. Well, I guess I can go ahead and try to draw it a little bit for you to remind you. So here's a neuron, and here's its axon, and then another neuron, and its axon, and another neuron, and then it has some sort of feedback loop that impacts an earlier neuron. So that what you end up with is, with this reverberation, is this is going to repeat for a while. Now these don't last forever, but because there's usually something that finally stops it, or if there's synaptic fatigue or whatnot. But this might be some of those circuitries that are involved in these short-term memories. Now let's take a look at the presynaptic facilitation or inhibition on the next slide. Now what we have here is finally a time where we're going to look at some presynaptic neurons that are axo-axonal. We've largely ignored the existence of these kinds of synapses, because here's the typical kind we've been looking at, the axon coming from a long way away, and then here is the axon terminus. There's the postsynaptic neuron right over here with its little receptors. Here we have an axon coming in this way. Like here's the little lower magnification view showing that you have an axon synapsing on the end of another axon, or an axo-axonal. And what these things might do is cause some, when they're stimulated, cause the release of some neurotransmitters. And in some cases it can be inhibition. This particular one I'm pointing out happens to be presynaptic inhibition, because GABA is inhibitory. Can actually abort the activity of this neuron. So here I have an action potential coming over here, and if this is happening at the same time, that will block some of that calcium entry, and so you'll have less neurotransmitters. So this would be one of those habituated types of short-term memories. In other words, not remembered. However, the kind of thing that might lead to allowing that memory to last for some time is the activation of one of those axon-axonal synapses where serotonin or a similar neurotransmitter might be involved, which is excitatory, which will accentuate how much calcium is entering, and more neurotransmitters released, which means you'll have more of an impact on the postsynaptic cell. So in the case of presynaptic facilitation, that might be one of those facilitating kinds of positive memory. But again, these are still neurotransmitters that open channels, and channel openings don't last very long, so this is again short term. What about intermediate long-term memory? Now, intermediate long-term memory has some similar looking mechanisms, and here we have another one of those axo-axonal synapses, but in these cases, instead of, say, serotonin or GABA, if there's an inhibitory one, instead of them activating direct ion channels to change the amount of calcium in the area, that it'll actually create a second messenger system kind of activation where cyclic AMP is around. And cyclic AMP might cause some or interact with protein kinases that will phosphorylate proteins that will be there longer and be phosphorylated for some time longer, which might ultimately lead to there being more calcium ions on a regular basis, not just in those few minutes. So they're thinking that intermediate long-term memory might be using mechanisms something like this. This has actually been demonstrated on some lower animals. This particular thing has been demonstrated for sure in lower animals, but there's no reason not to think that maybe something similar but maybe more elaborate is happening in us. Now, an example I said, cramming for exam might be in the intermediate long-term memory category, so unless you do something to help to review that over time, especially in preparation for national boards in your future, then it won't be in your long-term memory. There's no obvious distinction between intermediate and long-term memory because they think the mechanisms might be similar. It might just be a matter of degree and what is these second messengers doing to these synapses. Well, what they may think is happening is that these long-term memories that last for years or even a lifetime has to do with some structural changes in these synapses, as well as even chemical changes that will stay there indefinitely. So you might have an increase in the number of release sites for vesicles, increase in the number of transmitter vesicles that are permanently stored in those neurons so that they fire more readily, increase the number of presynaptic terminals, or even the dendritic spines in the postsynaptic cell may have some structural changes that make them much more sensitive. So those are all ideas about long-term memory. The term memory consolidation. Consolidation of memory means you're converting a shorter-term memory into a longer-term memory. So if you got that phone number and you repeated it to yourself over and over again, perhaps it will stick for a longer period of time. You will consolidate that memory into maybe intermediate long-term memory. If you dial that phone number a lot, of course none of us do that anymore because we have our smartphones with our, everything all saved on it. But in the old days when you had to remember people's numbers, that would be a way to consolidate it into a longer-term memory. Now the more often you use a particular memory trace, the more likely this consolidation will be effective. Now it's also interesting to note that new memories are codified. What that means is that memories about similar situations or similar things tend to be stored in similar places physically in the brain. And so that one thing will tend to remind you another if they are similar. My favorite example of this is, let's say you have a parent, a mother or a father, that has several children, and they all, of course, have names, certainly, but if they want to address their youngest child, sometimes they'll go through all the other names to get to the one they want, because all of those memories are consolidated in a similar place. So that would be an example. Memory is a little bit scary in that it is prone to error. So that we need to talk about some sources of these errors. One is absent-mindedness. I'm a professor, so I'm supposed to have this, right? Absent-mindedness. And that is a lack of attention to immediate experience. In other words, forgetting to pick up your milk when you were supposed to pick it up on the way home from wherever you are. Or walking into the kitchen from another room, like, what was I going to do? I was going to do something, I can't remember what I was going to do. That sort of thing is an error in memory. And those are really commonly increased as we age, unfortunately. Blocking, I think one of the more annoying types of errors in memory is when you can't name something, it's on the tip of your tongue. What's that actress that played so-and-so in this movie? That kind of thing. You just can't think of it for a while. That blocking sometimes comes to you later, but that's kind of an irritating kind of an error in memory. This one is dangerous, misattribution. In this case, you have an association of a memory with the incorrect time, place, or person. In other words, false memories, where perhaps you were witness to a purse snatching, and it so happens that you also, around that same time, saw an unrelated person walk by you, and then you made a mistake in your memory to think the person that was innocently walking by was the person who did the purse snatching. That's misattribution. They had kind of a mixing of memory or a establishment of the memory in some way, and that could put some people in trouble, right? Another one that could be also dangerous is something called suggestibility. This is a tendency to incorporate external information into memory, but usually because of leading questions or suggestions. So if you had a memory of a particular event, and let's say you talk to somebody else about that event, and that person says, well, I had this sort of thing happen similar to that, and then maybe over time that you incorporated what that other person said into your memory, and it shifted the memory of that event for you from now on. And now you swear up and down that that's the way it happened, but it might not have been. So suggestibility is kind of scary. So as you might imagine, the criminal justice system needs to be careful about these kinds of misattributions and suggestibilities, because witnesses can, even if they're being as honest as they can, they may have errors in their memory. So that's why I guess physical evidence is helpful. There's also the function of bias, that our own biases can distort our memory somewhat, so that your personal beliefs or your personal things that you had been brought up in the past, that seems to color and influence the way you view things and then remember things. And persistence, I don't know if it's really an error in memory in the same sense as all the other 5 are, but this is where you have an obsessive memory, where you remember a particular event over and over again. You can't get it out of your head. Something that just keeps running like a broken record constantly in your head. And even if you want to forget it, you just seem to not be able to. So that is called a persistence. what parts of the brain seem to be important in memory? Well, let's first look at the hippocampus. The hippocampus' job is to promote the storage principally of declarative memories, right? That's the who, what, where, when, why type of memories. And they also are the most important output areas for reward and punishment areas of the limbic system, meaning that the events in your life that you remember the best are the ones that have some emotional context. You know, a big milestone like graduating from chiropractic college. Yeah, I remember that, everything that happened that day. But, you know, like I said, some random Tuesday at some other time, I won't remember anything about that day. That kind of thing. Or even just painful memories would also be very powerful in consolidating memories. And the hippocampus are going to be interacting with those limbic areas to create these memories. Lesions of this area lead to anterograde amnesia. Anterograde amnesia. That means you can't consolidate new memories. So you might remember things that have already been consolidated, that you remember your past, but you can't remember what's happening now, and you can't learn anything new or remember anything new. The 50 First Dates or 40 First Dates, whatever that name of that movie is an example of this. If you haven't seen it, it's really charming. Thalamus is another important part of memory, and that is used for memory retrieval, so that you need the thalamus in order to pick memories that are already stored from your past and use them. So lesions of the thalamus tend to lead to retrograde amnesia. And this loss of your past has more to do with event losses, not necessarily loss of language. You know, you might still be able to talk, you know what words mean, but all of your past events are gone, which would be terrible. Actually, both of them are terrible. The amygdala is also an important area. And this also is important for memory consolidation, especially with those emotionally charged memories. So that's kind of related to what we were talking about over here with the limbic system some. So I wanted to particularly mention the amygdala as an important part of memory. Next time we'll talk about the limbic system in particular and its role with the hypothalamus.